Oh, gosh. I blame Kelford. Okay, listen. Shh.
It rolled all the way over there.
Yeah.
I feel so stupid.
Yeah, I didn't know that you could look through the glass.
Now you know. Did you think it was a picture?
I don't know what I thought it was.
That's fair. Okay, so are you like birds see their reflection and they aren't intellectually capable of knowing that's not another bird?
No, she just didn't.
So like my daughter has birds and they will just stand in front of the mirror and chitter away with themselves for a long time, really. Anyway.
Is that Mr. Dash?
Yeah. Yeah, he's great. He's like me, but smart and friendly.
My brother stole his guitar the other day.
Okay. Shh. We've got here a number of three-dimensional shapes. Now, what does the term volume mean?
Volume, like in your hair. You know the volume.
Sure, which means it gets,
Bigger.
yeah, it takes up more
Space.
Good. Volume is a measurement of how much space something takes up. Does that feel okay? That's comfortable? Now, we instinctively understand volume, right? We understand that if you make all the dimensions of something bigger, it takes up more space. And if you make all the dimensions of that thing smaller, it takes up less space. That feels logical, right? If I took this and made it twice as tall, it would be able to hold twice as much water. Is everyone comfortable with that? And if I made it 3 times taller, it would hold 3 times as much water. And 5 times, it holds 5 times as much, blah, blah, blah. What if I made it not tall at all? What if I made it have no sides, just the flat bottom? Then how much water could it hold? None. So, if you think about it, volume depends on 2 things. If we look here, the first thing it depends on is how tall it is, right? We said if you make it taller, it holds more, and in a really logical way. Twice as tall, twice as much stuff. 3 times as tall, 3 times as much stuff, so on and so forth. What if we just change the size of the bottom? Here, I have a rectangle, and here I've cut it right in half to make one that has a square bottom. First, obvious, which one of these holds more? Yeah. How much more? Double. Because if we make the bottom twice as big, it holds twice as much. Does that make sense? So, for any shape, there's 2 things that matter. And I'm just going to kind of sketch it here. We need to know how big the base is. So the area of the base times the height of the thing. Whatever that thing is, try not to be intimidated by my intensely scientific terminology, but how tall it is. Does that make sense? That these are the 2 things that affect how much liquid will fit in there? We can change the volume by making the base bigger or smaller, or we can change the volume by making the thing taller or shorter. If we are right about this, how many of these should it take to fill this? 2. Let's see if we're right. I happen to have a fish tank over here.
Why is it such a little bit close?
Because I'm teaching optics. If time permits, I'll show you what we're doing after.
You don't know.
Yeah, hey, there might be. Oh, that doesn't make you laugh. I don't see why my misfortune should make you happy. But hey, so if we take a look here, and I lost a little. So there we go. We'll let that kind of drip down. So one of those fills it. Does that look roughly halfway?
Yeah.
And a second one should fill it all the way. And obviously I'm not being super careful here. But lo and behold, pretty much perfectly right to that line.
Drink it. Drink it.
Yeah, nothing I want to do but drink out of an old fish tank. That sounds like a great idea.
Get a straw.
God, you people are hired. Okay. Does that make sense?
Yeah.
So we're going to give you the formulas, but I want to say these formulas don't come from nowhere. The formula for every shape's volume if it is a simple shape, is how big is the base, and then how high up does it go? Does that make sense? So let's look at the rectangular prism. That's the one we just looked at here. Now this formula sheet's in a weird order, but I intentionally matched it to the formula sheet you'll get when you do the EQAO, and this is the order it's in. So hey, whatever. Let's talk about this one. How would we figure out how big the area of the base is? It would be, you'd measure it, and you'd do length times width, and then we have to multiply that by how tall it is. So we would say times height. Does that make sense? That's where that formula comes from. Length times width tells you how big the base is, and then you multiply it by height to say how tall it is. And those are the two things you need to know. So we can say the volume of a rectangular prism is equal to length times width times height. But again, we'll just make a quick note how big the base is and how tall it is. Okay. Next shape. This is a triangular prism. Does the same thing work? Not the exact same formula, but does the same idea work? If I make the bottom bigger, will the volume get bigger? Sure. And if I make it taller, will it get bigger? Now this one has a slightly different proportion, but see if you can eyeball it. How much bigger is this one? How many of those would fit on there? Here's one. Here's two. There's three. And there's four. Do you want to see that again? Maybe I'll have you look through it. There's one. Right? We all see one. There's two. There's three. And there's four. So this one is 4 times bigger at the base than this one. Will it hold 4 times as much water?
No.
Well, let's find out. I think it will. I hope so. It should, right? Because are they the same height?
Yeah.
So the only difference is the base. So if we think we understand this right, because this one has a base that's 4 times smaller, it should hold 4 times as much water than the big one. Yep, on my desk. Let's try it. Let's find out. We'll go back to the fish tank, which I still will not drink from. All right. There's one. Does that look like we're maybe a quarter of the way up? Looks promising. 2. 3. I definitely like all the stuff off the sides, and half of what was my hand went there too. So I think this is probably going to go a bit too much, but that's okay. And 4. Not bad, bit too much, but it does work. I just, on that second one, was like, hey, let's put as much extra water in as I possibly can. So 4. The bottom is 4 times bigger, it holds 4 times as much. Does that make sense? Again, the two things that matter, how big is the base, and how tall is it? Okay. And do we know how to find the base of a triangle?
Yeah.
Yeah, and listen, look what they've done here. And again, this sucks, but it is how they do it. They are now calling it the base and the length, which is stupid. But otherwise, what would you call this? You could maybe call it base, height, and depth if you wanted to imagine it going back. That might be better to imagine, right? But whatever you want, the important thing is, how do we find the area of this bottom part? It doesn't really matter what you call the sides. What matters is that you remember that a triangle has to be,
Half of a rectangle.
it's half of a rectangle, so we have to divide it by 2, and then we still multiply it by how tall it is. Because again, the important thing is it's how big the base of this thing is multiplied by how tall it is. That's the main thing. I don't want you to just have these as formulas that you use. I want us to understand where they come from. Does that make sense? Okay, so we could say the volume of a rectangular prism, or not a rectangular prism, sorry, a triangular prism. That is the worst triangular prism anyone has ever drawn. Perhaps I will try again. That looks a bit better. Is base times height times length divided by 2. Doesn't really matter what you define as what, as long as you get the sense that we have the triangle on the bottom and we're multiplying it by how tall the thing is or how long the thing is. Yep.
Dividing all of it.
It doesn't matter. It doesn't matter where you divide by 2. What this is saying is you multiply all these things together and you divide by 2. You could do base divide by 2, then multiply by h, then multiply by l. You'll get the same answer. You could do base times height, then divide by 2, then multiply by length. As long as the 2 is what comes after the division, the order doesn't matter. Does that make sense? It would be equivalent to saying, is there any difference between saying 2 plus 3 minus 5 plus 8, or, hey, first do 2 plus 3 plus 8, and then after you've done that, subtract 5. It's going to give you the same answer. Does that make sense? So likewise with multiplying, there's no difference between saying take the base, divide it by 2, then multiply by these other things, or take the base, multiply it by the height, then divide by 2, then multiply it by the length, or multiply all 3 of these together and then divide by 2. They all give you the same answer. So usually to make it clean, we write it this way. Did that answer your question? Wow. Look at me answering questions. All right, but wait a minute. These are not the only shapes. We also have a cylinder, but that's okay. What is the shape on the bottom of this? A circle. Now, this one can be harder to visualize. I wonder if Kelfords can be mad that I've taken all these apart and then gotten them wet. I think that's what they're for. I hope that's what they're for. These are the same height, but the bases are different size. Now, it is really hard to know how much bigger this is. I think it's 4 of them. Don't you think?
4 or 5.
I think because it looks like it's half the radius, and of course, because the radius gets squared, I think this is 4 times smaller. I think it's going to take 4 of these to fill one of those. Shall we check? Let's check. And this time I'm not just going to throw half of the fish tank in there on the second one for no good reason. All right, so there's 1. There's 2. Most satisfying plop sound. That's 3.
Yeah, I heard that. I was like,
And 4, and it's perfectly to that top line. All right, because if the circle is 4 times smaller, then it takes 4 of them to fill it. Because again, what are the 2 things that affect volume? For a nice extruded, for a nice extruded shape like this, it is how big the base is, than how much you've extruded it by. Has anyone ever done any like 3D work, whether like in Inventor or in AutoCAD or in Blender? Well, we'll talk about it. Anyway, let's wait till just 2 more minutes till we've got this done, and we've got Shelby back. All right, how do we find the area of the base of this thing? It's a circle. And how do we find the area of a circle? Yeah, very good. That's exactly right, though usually we'd write it in the order pi r squared. And then we're going to multiply that by how tall this thing is, which is just its height. So the volume of a cylinder is easy. It's pi r squared h, pi r squared times height. But again, that's not some magic formula. It makes sense. Pi r squared tells you how big the base of this thing is, and the height tells you how far you've pulled it up. Those are the two things that control how big a three-dimensional object is if it's a simple extruded shape. How big its base is, and how tall it goes up. All right, so we're done. We've got all the shapes.
No.
I think we're done. We've done all the shapes. We've done one with a rectangle base, we've done one with a triangle base, and we've done one with a circle base. And that's all we have here. Rectangle bases, circle bases, and triangle bases. Sorry?
This is called being disrespectful.
Who am I?
Disrespect the other shape.
I was confused. This is disrespectful.
Use it code.
Ah. The problem is, that assumes that they just get brought up in a straight line, a simple extrusion. Which, by the way, really quickly, like, when we build things, extruding is like the most basic way to do it. If you take shop and tech long enough, you'll use Autodesk Inventor, almost for sure. And in Inventor, we draw things in 2 dimensions and then extrude them into the 3rd dimension, which means just pull it up, but don't change its shape. You just pull it forward. Does that make sense? Wow, Inventor, you're slow today. Oh, it's installing an update. Okay. So like I'll show you a project that I worked on. Let's see if I can open. Yeah, so for example, I ordered a new mantle for my fireplace. Where is this? I ordered a new mantle for my fireplace made out of stainless steel. I had it fabricated. I had it welded at a shop. And because I tend to do things, some might say overdo things, I made plans. Can I show you my plans? So here we go. This is what I wanted. Then I gave very detailed step-by-step instructions for each thing I needed so that I could get them manufactured just how I wanted. There we are. Does that make sense? But when I actually went to build that, the way you do that is I said, like, say the inner mounting plate, which just looks like this. That's the object I need. What we actually did was we just sketched it out in 2 dimensions. Does that make sense? And then we extruded it. We just said, hey, take that thing and bring it out by a certain amount. And I could finish this sketch, just like that. And you can see it just took the shape of the thing and all it did was put it into 3 dimensions. Does that make sense? That's an extrusion. It's the simplest way to make something 3-dimensional. That's not the only way to make something 3-dimensional. Instead of having it come straight up, we could also have it come up to a point. So sometimes we don't extrude, sometimes we bring something up to a point, which, of course, gives us a problem. I'm so going to make Kyla put this back together. Okay, real simple. The base of these is, and they happen to be the same square. Does that make sense? Okay. In fact, I can put the lid for one into the other. They're the same lid because the bases are the same. Does that make sense? All right. So they have the same base, and the heights are the same. Same base, same height, but obviously one is bigger than the other. Which one's bigger? Well, they're both, neither of them is a triangle. They're both.
Has a bigger heart.
Which one's bigger? The prism or the pyramid? The prism is obviously bigger. How much bigger? How many of these will it take to fill this? Two? 1.5.
I don't know.
Anyone think more than 2? 5, 10, 58?
20 million?
Should we find out? Let's take a look. Back to the fish tank. Actually, can I get a couple volunteers? Alright, get over here. Get another volunteer? Brooklyn? Yeah, okay, get over here. Alright. You, hold that. You. Okay, we're going to carefully, now listen, the fill line on here is below where the lid would go in, so the lid fit. Does that make sense? I want you to fill that up just to that fill line, and then carefully pour it to there. Alright, you two be a team. That's a lot of time to do that. I forgot my first rule, which is never do any work when you can make a kid do work. No, that's good. That's good. You're doing great. All right, that's one. Anyone want to update the guess as to how many it's going to fit? Ooh, let's see. I think you're right. It's a little overfilled, but that's all right. The second one's overfilled, but that's okay. And let's see the third. I think we'll probably still over. You want to be under that, like just on that lip. You got to put it straight. You're definitely too much. Still too much. That's the one. Very good. And because that second one was a bit full, we end up a bit full, but still pretty close to perfect. 3. Awesome. You can dump that out. Well done. Let's thank our volunteers. What is the other shape that? What is the other shape that comes to a point? What's the other shape that comes to a point? You can put these here. Thank you, just on the desk. The cone and the, what do we call this again? Cylinder. Thanks, guys. Can I get another couple volunteers? You. And you, get back here. Sorry. You did volunteer to come to a fish tank or recording water. There you go. Same spiel when you pour it. It's below that lip there. Okay? All right, so same thing. We have another shape that comes to a point, and just looking at them, how many, hold them up, how many of those to fill that? 3. Let's see if we're right. I think you're right. Let's see if it's true. Again, just make sure you go just to the lip, not all the way to the brim.
I think she's got a better strategy than I do. Yikes.
That looks good to me. All right, there's one. Looks pretty good so far. Yeah, I don't want to say that makes you look bad, but
It makes you look
making you look pretty bad. 2. And one more. I think we're perfect. I think it's going to work exactly right.
making you look like an idiot.
Perfect. So there we see it. You guys can dump those and go back on that desk. When a shape comes to a point, how much smaller does it get?
3 times.
It gets 3 times smaller. When you take a shape and instead of extruding it up to a flat surface, you draw it up to a point, it gets smaller. How much smaller?
3 times.
3 times. So we can write these formulas. We got this. Here, instead of being a rectangular prism, if it's a rectangle that comes down to a single point, how do we calculate the volume of that? We take this one, length times width times height, and we divide it by 3.
What if there's 2 points?
That's actually a good question. Because when we get to the sphere, there's an infinite number of points, but we'll get there. Okay. Coming to a point is 3 times smaller. Again, you don't have to have these formulas memorized. You'll always have them to look up. They'll always be there. But it helps if they're not just random letters. Do you know what I mean? It helps if you understand it. So what does this mean? It means take the base, multiply it by how tall it is, and then divide it by 3 because by coming to a point, it gets 3 times smaller. What will the formula of the cone be then? You're going to tell me the formula for the volume of a cone despite never having been told the volume for the formula of a cone because you know how this works. Take a minute. Put your hand down. Everyone write down the formula for the volume of a cone. Worst case scenario, you're wrong, but I bet you won't be. And in fact, they don't even have a triangular pyramid on here, but I bet you could figure out a triangular pyramid. Because you all be clever. Well, right now I want to know for the cone. Everyone write down. All right? Don't wait for me. Man, do I hate that. Be bold. Be brave. Yeah?
Pretty sure it's wrong, but pi r squared times height divided by 3.
Perfect. Pi r squared times height divided by 3. Now listen. Look at me. You just figured out the formula for the volume of a 3-dimensional object from first principles, all by yourself. And you're only a grade 9 student. Seriously, think about that. And we did it by pouring some water into some cups and paying attention. That's math in action. It's very well done. Good. These are the formulas we're going to use in this course to find the volume of stuff and things. So let's try with each one. I want you to take 4 minutes. Well, no, I want you to take 8 minutes and answer all 4 of these. All right? You may. All right, so take 8 minutes, find the volume of each one of these, and when you have done so, then we'll take them up. Talk to each other. If you're not sure what to do, should you sit at your desk and do nothing?
No.
Should you talk to your neighbor about unrelated things?
Yeah.
Should you be sad?
Yes.
No. Put your hand up. Say, hey, help me out. I'm here to help. That's what I do. I'm here to help kids with math and chew bubble gum and all out of bubble gum.
And then stick it under your desk.
No. No.
Yeah, stick it under.
Just swallow it. God, I don't get people with bubble gum. Just swallow it. You swallow literally every other food you eat. And then there's this one where we're like, ooh, you know what I'm going to do? I'm going to chew on this for a long time. Then I'm going to reach in with my hands and take it out of my mouth. Why? Just swallow it.
I spit it out.
Can't you spit it out?
Of course you can. What do you mean you can't? Yes. Allow me to demonstrate. Oh, you just did it. That's it. That's all you do.
It's not that easy.
Yes, it is.
No, it's not.
It is entirely psychological what you're describing right now. I promise you. If nobody had ever told you that you're not supposed to, you'd just swallow it like everything else because it's just food. It's not like magic food that somehow sticks to your face. It just...
For a long time, if everyone told you to swallow it.
Sorry?
If someone told you to swallow it, you would chew it for a long time.
Okay.
Because the whole point in it is to chew it for a long time.
Okay, so chew it for a long time. But then when you're done chewing it, swallow it.
Yeah, but you'd be done chewing it quicker if you knew you were supposed to swallow it.
Why?
Because that's what we do with every other food. If everyone told you just to swallow it. you
Okay, well listen, all I know is that there's just this one food. Every other piece of food we eat, there's this kind of policy where like once it's in your face, don't take it out. That'd be considered poor manners. Do you know in Singapore, if you chew gum on the subway, what they do with you? I know this because my uncle lived in Singapore.
No, we had no idea.
They fine you. You know what happens if you do it a third time? This is true. They cane you in a public spot. Literally, they get a cane and they hit you with it in a public place as punishment. That's a real thing. Famously in the 90s, there was an American tourist who spray painted the subway in Singapore and they caned him. They took him in a public space. They got a cane. They hit him with it. It was a big international incident. But I'll tell you something. You know what you don't see in their subways? Graffiti or gum. No gum on the bottom of those seats. My uncle lived in Singapore and my mother went there to get married and she took confetti to throw at the wedding. This guy ran up and said, "Oh no, if you do that, they'll cane you." So she didn't throw the confetti. So now you
I
know.
like that. No littering. I would appreciate
Yeah.
that. I appreciate that.
I don't agree with hitting people to make people not do things. I think that's bad.
Yeah, they got
But I will say this. If we did, imagine if you came in and you're like, "Hey, I don't have my homework done." And I was like, "No worries. Let me just go get my cane." Thwack, thwack, thwack. You'd probably get your homework done the next time, right?
You know,
I think you,
Probably actually call the
Casey, I think you would.
I'm traumatized and maybe not
Realistically,
Yeah, what?
call the police and not show up.
Yeah, when you get 2 of these done. 2 of these done. That's the deal. Yep. For the record, I would definitely not hit anyone. I'm not wired that way. But it is interesting to think, but to be clear, it is weird to think that like not that long ago, like my dad got the ruler and the strap when he was in school. That's not that long ago. That's like the 70s.
That's amazing.
It's crazy, right? Like, could you imagine if your teacher was just allowed to say, "Hold your hand out," and then take a leather strap and hit you with it? Like, that's crazy. But that's just what they did.
I would lose my hand.
Or you'd be well paved.
Imagine my grandfather.
You'd be traumatized. You'd probably go insane.
Yeah. Yeah, for the record, I don't believe in corporal punishment. I think it's a bad thing. But again, you wouldn't have been able to, right? Because it's interesting to this day. Do you know what the legislation says for teachers? This is actually how the law is written. A teacher is able to discipline you by acting like a reasonable parent. That's actually what the law says. In other words, when you're at school, well, but seriously, and so in the 1970s, that's what parents did, right? Like they smacked you around. And not just some, but that was like considered good normal parenting. We no longer consider that good normal parenting. We consider that inappropriate parenting.
Yeah, look how it turned out for that.
Well, I don't know. They turned out all right, but like they didn't. I'll let my parents know they turned out poorly. But I agree. I think it's damaging. I don't believe in
Even
it.
if you turned out fine, I still think there's a little bit of damage.
Oh, I guarantee there is. I think. Did you? Can I see them?
The parents did okay to their children, but their children now are horrible parents to their children.
Yeah.
All right. Now I want you to put numbers in. I want you to put in your calculator. So now, what's the length of this?
14,
And the width?
9,
And the height?
20.
Awesome. Then divide by 3 and go. You got this. I have faith in you. Casey, have I told you guys my embarrassing Batman Begins story?
Yes.
Yeah. That made me think of that one. Have I not told you? In Batman Begins, where he's got the drug dealer by the feet and he's like, "That's all I know, I swear to God." And he goes, "Swear to me." And then he drops him. And so one time this girl, I made her give me her phone and she was like, "Oh, I swear to God." And I was like, "Swear to me." And then she just looked at me like I was the weirdest freak in the world. And I was like, you haven't seen that movie, have you? And she had not.
Tell Shelby what she missed.
Yeah, you bet.
Okay, so
Anyway, Casey, that was a very good moment. I thought it was good. You gave me a very good angry look. You're a fan. Don't even pretend. Yes, you are. Yes, you are. You're going to go around the hall all afternoon and be like, "You know, my favorite teacher is that Orlando. What a good guy."
She'll sit on call.
Yeah, see? There you go.
Yell at you. She'll sit on
Here,
call
which
for
one's
hours
this?
and hours
There's
on
this.
end. I don't know
And
how
then
many
there's
hours.
the square.
Yeah, I wouldn't know.
Yeah, the same one. There you go.
And then there's
And do you want the cone and the cylinder? Yep.
the,
There you go.
I know. I've never taken it back from my mom.
Do you not have a phone right now?
No, I don't. It's been taken away from mom. Don't laugh. I don't want your phone. It's not. No, take my grades. Take my grades. Oh, I will take your grades. Yeah.
shut up.
9 more minutes. I'll
I
send
need
you a
cylinders.
screenshot of mine.
Alright, please have this is Orlando. I
You
can
can-
explain to her the home one if I don't have.
Scratch it.
What do you
I
want?
just need that one.
Okay.
That's it.
You can take mine.
All right. Guys, let's take a look at these quickly. Which one of these is the easiest? I like to do the easiest one first. Yeah, we don't have a square, but we got a rectangular. So I like that. Okay, what's the volume of a rectangular prism? Yeah.
Length times width times height.
Length times width times height. All right. Shh. Is your page empty?
No.
No? Show me. Show me. Hold it up. You all that time in your page is empty? Oh, so that's a problem for me. We got a problem. I don't like that. I don't like that one bit. Now I'm angry. 2 minutes ago I was not angry. Now? Angry. Oh, problem. All right. Talk to me. What numbers go in here? So what'd you do in that time exactly? I give you time to work, you just don't? Yeah, we gotta do better than that. No, thank you. All right. Shh. Somebody talk to me. What's the length of this thing? Yep.
10.
Yeah, I like that.
And the 8 is the width.
Very good. So we have 10 millimeters, and then the width is 8 millimeters. I like that. And then what's the height?
3 millimeters.
3 millimeters. Cool. Okay, when you multiply that together, what do you get?
240.
240. And then talk to me about units. So we have 240 as the number, and then millimeters times millimeters is very good. Millimeters cubed. The other way to remember that, we're talking about a three-dimensional measurement, so we need a three-dimensional unit. Yeah, I love it. All right. What's the next one we should do? How about can we do this one? What's this thing called? It's actually a rectangle on the bottom. So this would be a rectangular pyramid. Good.
Sorry, I'm so tired.
That's okay. Why are you sorry? God, we're doing this for the first day. You're supposed to know everything off the hop.
Yes.
Don't be hard on yourself.
It's a basic shape.
It's a basic shape. All right, well, I'm not judging you. You can judge yourself if you like. The volume of the rectangular pyramid, what's the formula for that?
Length times width
Length times width
times height
times height.
divided by 3.
Divide by 3 because it comes to a point. And when something comes to a point, its volume is 3 times smaller. So what numbers will go in here?
14.
14? What? 14 what?
As the length.
Yeah, 14 carats.
Oh,
Yes.
14 yards. Cool. All right, multiplied by
9 yards
9 yards. Cool.
and 20 yards.
And 20 yards. Awesome. Very good, guys. So 9 yards and 20 yards. And then, oh man, 20 times 14 is 280. And that times 9, well, that times 10 would be 2,800. So this is going to be 2,520.
You have to
divided by
divide by 3.
And then we have to divide that by 3. And that divided by 3 will be 840.
yeah.
Hey!
Hey!
Hey! Hey! And the unit will be yards times yards times yards, which is yards cubed, a cubic yard. That's a lot. One day I'll tell you about the time that my wife's boss accidentally ordered 27 cubic yards of manure to fertilize her garden. It was a unit mishap and a misunderstanding of how big a cubic yard is. And it was a very large pile of manure on her front driveway. Problematic when you live in a nice neighborhood, or any neighborhood for that matter. Not big enough for 27 yards, let me tell you. All right, what about this? What is the formula for the volume of this guy?
Pi r squared h.
Pi times r, we square that and we multiply it by h. All right, talk to me. What can I use for pi? 3.14. What is the radius of this one? Be careful. It is 4 because we have to go halfway here. Listen, if you used 8, that is totally natural. If you caught on and put that as 4, I'm very proud of you. That's tricky. What do we need to make sure we do with that? Square it, and then we have to multiply it by the height, which in this case is 12 centimeters. All right. 4 squared is 16. 16 times 3 is going to be on the order of 48. 480 plus another. We're going to be in the ballpark of like 560 or so. Or we're not because I might have screwed up. Talk to me. What do we get?
602.
Darn it, that's more than I said, but that's okay. 602, and then what's our unit? 0.3 centimeters squared, and then another 1 centimeters cubed.
Excuse the interruption.
No!
On today's cafeteria menu, we have Tapas Tuesday, which includes hummus platters for $3, 2 mac and cheese balls for $1.50, pizza bites, 2 for $1, cheese sticks for $1, and pork kebabs for $1. So potato bacon soup for $2. Thank you.
All right, last one. Oh, my voice just cracked.
Whoa, man.
I feel like I'm back in grade 7. All right, what's the volume of a cone?
The cylinder, but divided by 3.
So pi r squared times h, but it's got to be divided by 3. So in this one, that means what?
3.5 squared.
Well, pi is 3.14. What's the radius?
3.5.
And we have to do what with that? Square it. The height is?
13.
And then what do we have to do with this whole thing?
Divide by 3.
Divide by 3. So that should be on the order of, I don't know.
166.7.
Let's see, I was going to say 210, so never mind. What is it?
166.7.
And what will our unit be?
Cube. 3.
Cubic inches. Cool.
Cube.
Okay. Sometimes you're used to buying a yard of fabric, which is a linear measurement, and you kind of picture that when ordering a yard of manure, which is 3-dimensional, and you order a lot of manure. Anyway, that's a different discussion. I'll see if I can find a photo. It was rather comical. Okay, listen up. Oh, look at me. Sit down. I didn't say stand up. I want all these done for homework. Everything that says practice, 2 pages, get them done. Should not take you long. We'll check that tomorrow. Make sure you get good at this because we're going to have to use this. Have a wonderful